There's a quiet assumption most of us carry without noticing it. The idea that when we look at something, we are seeing reality itself. Maybe not perfectly, maybe blurred, maybe biased, but still, directly, this assumption feels harmless, necessary, even. Science seems to depend on it. And yet, the deeper physics went, the more uncomfortable this assumption became, not because reality is mystical or unknowable in some poetic sense, but because the very act of observation turned out to be the wrong question. This is where it gets uncomfortable, because physics does not actually describe what is. It describes what we can observe, measure, and predict, and those are not the same thing. For a long time, no one noticed the difference. If you go back to classical physics, everything feels reassuringly solid. Objects have positions. They move along paths. If you know where something is and how fast it's moving, you can calculate where it will be later. Observation in this world is passive. You look. The universe doesn't care. Newton's laws work because they assume this quietly in the background. You can measure without consequence. You can observe without interference. And for everyday objects, this works so well that it feels like a law of nature. You look at the moon. The moon does not change because you looked at it. So we built an entire intuition around this idea. Reality exists out there. Observation just reveals it. But physics has a habit of breaking intuitions that work too well. The first cracks didn't come from the very small. They came from light. Light behaved badly. Sometimes it acted like a wave, spreading and interfering. Sometimes like a particle, hitting detectors one at a time. This wasn't just confusing. It was structurally disturbing, because waves and particles are not two versions of the same thing. They are different concepts entirely. Physicists tried to fix this by choosing one, then the other, then both. None of it held together. Now, this sounds like a technical problem, but buried inside it was something deeper. To know what light really is, you had to measure it. And the way you measured it determined what you saw. If you measured interference, you got waves. If you measured impacts, you got particles. This wasn't about poor instruments. It wasn't about ignorance. It was fundamental. Most people misunderstand this next point. The problem is not that observation disturbs reality in a practical sense, like touching a fragile object. The problem is that observation is not separate from the physical situation at all. Measurement is a physical process. It involves interaction, energy transfer, forces. There is no such thing as just looking. At first, this seems like a minor correction. Of course, measuring something involves interaction. But here's the part textbooks avoid. At very small scales, there is no meaningful way to talk about a system before it is measured in the same way you talk about it after. Not because it's hidden, but because the properties you're trying to observe are not defined independently of the measurement. This sounds wrong, so let's slow down. Imagine asking, where is this particle right now? In classical thinking, that's a valid question whether or not you look. The particle has a position. Your measurement just reveals it. But in quantum physics, position is not a permanent label attached to the particle. It's a result produced by a specific interaction. Change the interaction, you change the question. Change the question, you change the answer. Not because the particle is being tricky, but because the theory only tells you probabilities of outcomes for measurements. We calculate, we predict, we test, and the predictions work with absurd accuracy. But notice what's missing. Nowhere in the calculation does physics tell you what the particle is doing when you're not measuring it. Not because we haven't figured it out yet, but because the theory does not require that description to make correct predictions. This is deeply unsettling because it suggests that what is happening is not a necessary ingredient of physical law, only what happens when we measure. This is where people often panic and start talking about consciousness, or observers creating reality, or the universe needing to be watched. That's not what's happening. There is nothing special about a human observer. A detector works just as well. So does a screen. So does an atom. Observation in physics is not awareness. It's interaction, and interaction is unavoidable. Even light itself used to see things, changes what it touches. You cannot see an electron without hitting it with something. And whatever you hit it with transfers momentum. This isn't a technological limitation. It's built into the structure of the theory. You cannot remove yourself from the experiment because you are part of the experiment. This is where the phrase, "you can never observe reality directly," stops being philosophical and becomes technical. What you observe are outcomes of interactions. Detector clicks, spots on a screen, readings on an instrument. You then build a model that predicts the statistics of those outcomes. The model works, but the model does not grant you access to a hidden movie playing behind the scenes. Most people assume physics is incomplete because of this, that one day we'll discover the deeper layer. Maybe, but here's the uncomfortable truth. Every time physics tried to restore a fully objective, observer-independent picture beneath the measurements, it ran into contradictions. Not emotional ones, mathematical ones. The more you demand that particles have definite properties at all times, the more the predictions break. Experiments don't allow it. This is where it gets really uncomfortable, because it means the universe is not obligated to make sense in the way our intuition demands. It is only obligated to be internally consistent and experimentally accurate. And it is. We don't get certainty. We get limits. We don't get direct access to reality. We get constraints on what can be said about reality. Think about temperature. You don't measure temperature by touching individual atoms and asking how hot they feel. Temperature is a collective property. It emerges from averages. At the atomic level, the concept dissolves. In the same way, position, momentum, trajectory, these are not universal truths. They are concepts that apply only under certain conditions. Push outside those conditions, and the concepts stop working. Not because reality becomes mystical, but because the questions stop being well defined. This is not a failure of physics. It's a clarification. Physics is not a window. It's a filter. It doesn't show you what is. It tells you what can be predicted, and prediction is always tied to measurement. Here's the part that's hardest to accept. Even in principle, there is no experiment that reveals reality without shaping it. There is no neutral vantage point, no God's eye view. Every measurement defines the framework in which the result exists. You can't step outside that framework, because stepping outside would require interaction, which puts you right back in. This is why debates about what's really happening behind the equations never end, because the equations already contain everything that can be tested. Anything more is a story you add on top. Some stories are useful. Some are misleading. None of them are required. Now, this doesn't mean reality doesn't exist. That's a misunderstanding. Reality exists strongly enough to resist your expectations. It pushes back. It constrains. If your theory is wrong, experiments fail. Nature does not negotiate, but reality does not offer itself up for inspection on your terms. It answers only the questions that can be asked physically, and those questions are always shaped by how you ask them. This was not obvious at first. Physicists fought this idea hard. They tried to keep determinism. They tried to keep hidden variables. They tried to keep the comforting picture of particles carrying secret instructions. Each attempt collided with experiments, not vague experiments, precise ones. Again and again, the universe chose consistency over comfort. So we adapted. We stopped asking what particles are. We started asking what happens when we measure them. And strangely, the moment we stopped demanding a direct picture of reality, the predictions became perfect. This is the trade. You don't get to see reality directly, but you get a framework that never lies when used correctly. Now, here's the quiet part people rarely sit with. If observation does not reveal reality directly, then neither does thought, nor imagination, nor intuition. All of those evolved to deal with mid-sized objects moving slowly compared to light. They are not truth detectors. They are survival tools. Physics works precisely because it distrusts them. It replaces intuition with calculation, stories with experiments, and what it finds is not chaos. It's order, but an order that does not care how we would prefer to understand it. We calculate probabilities. We predict distributions. We test outcomes. And nowhere in that process do we require a story about what reality is doing when we're not looking. This is not ignorance. It's discipline. It's the recognition that asking for more may not be meaningful. So when you hear that you can never observe reality directly, don't hear it as a failure. Hear it as a boundary that tells you where physics ends and storytelling begins. The unsettling part is not that reality is hidden. It's that reality does not need to be fully revealed to be completely predictable. That feels wrong, because we're used to understanding meaning as coming before numbers. Here, it's reversed. The numbers come first. Meaning is optional. And that is why, after everything we've learned, physics feels less like a mirror and more like a constraint. It doesn't show you what the universe is. It tells you what the universe will not allow. And maybe that's all it ever promised to do. At this point, most people want reassurance, some sense that beneath all this abstraction, there is still a solid world waiting to be uncovered. Maybe there is. But if there is, physics has no obligation to give it to us, because physics is not about revealing ultimate reality. It's about surviving contact with it. And it does that by teaching us something quietly devastating, that understanding does not require direct access, only consistency. You can predict without seeing. You can know without picturing. You can be right without being comfortable. And once you really accept that, you don't feel enlightened. You feel slightly ungrounded, because the universe no longer owes you a picture, only results. And it delivers those relentlessly, precisely, and without explanation beyond what can be measured. That's the uncomfortable truth. Not that reality is unknowable, but that knowing was never what physics was offering in the first place. For a while, this realization stayed confined to the very small. Electrons, photons, atoms. It was easy to tell ourselves a comforting story, that the weirdness lives down there. That the macroscopic world, the world of tables, planets, and people, returns to something sensible. And in practice, it does. When systems get large, the uncertainties average out. Probabilities sharpen into near certainties. Trajectories reemerge. So it feels like reality becomes observable again. But this is an illusion born of scale, not a change in principle. The underlying rule never disappears. It just becomes harder to notice. Even when you look at something large, what you actually observe are still interactions. Photons scattering, electrons moving in sensors, chemical changes in your eyes or instruments. You never step outside the chain. This matters because it means the problem is not confined to quantum mechanics. Quantum mechanics merely exposes it. Classical physics worked because it quietly ignored the question. It assumed that properties existed, whether or not we measured them. That assumption was never tested at small scales because it couldn't be. Once it was tested, it failed. So the discomfort we feel is not about quantum theory being strange. It's about our original assumption being wrong. That assumption, that observation reveals reality directly was never a law of nature. It was a habit of thought. Now, here's a subtle point most people miss. When physicists say you can't observe reality directly, they are not saying reality is subjective. They are saying something colder. They are saying that the concept of reality as a collection of definite properties independent of interaction is not required by the laws and is often incompatible with them. This is a statement about structure, not perception. The universe is not blurry. Our descriptions are constrained, and the constraints are precise. You can know the distribution of outcomes with extraordinary accuracy. You can predict interference patterns to many decimal places. You can build devices that rely on these predictions and have them work every time. What you can't do is demand a single, continuous narrative of what is happening between measurements. Not because it's forbidden, but because it's undefined. That difference matters. Undefined does not mean hidden. It means the question does not map onto anything measurable. It's like asking what time it is at a place before clocks existed. The question feels meaningful only because we're used to the framework. Remove the framework, and the question dissolves. This is where people often accuse physics of being incomplete. But incompleteness would show up as failed predictions. Instead, what we see is the opposite. The theory works too well. Every attempt to complete it by adding unseen details, extra variables, carrying secret information ends up predicting something that does not happen. The universe refuses the extra structure. This is deeply unsettling if you believe that understanding means visualizing. That knowing requires a picture. Physics does not agree. It offers you rules for calculation, not a cinematic experience. And this becomes even more disturbing when you realize something else. The limitation is not on reality. It's on explanation. Reality behaves consistently whether or not we understand it. The limits appear when we try to describe it in classical terms that no longer apply. So when someone asks, what is the electron really doing? The honest answer is not, we don't know yet. The honest answer is, the question assumes a kind of behavior the theory does not define. We can tell you what happens when it interacts. We can tell you the probabilities. We can tell you how those probabilities evolve. That is the full content of the theory. Everything else is surplus. Now, here's another uncomfortable turn. If observation is interaction, and interaction is unavoidable, then the idea of a perfectly isolated system is a fiction. Useful, powerful, but still a fiction. In practice, we isolate systems well enough that the predictions work. But in principle, nothing is ever completely untouched. This means the universe is not a collection of independent objects. It is a web of interactions. Objects emerge as stable patterns within that web. They are not the starting point. They are the result. This reverses our intuition. We think objects come first, interactions second. Physics suggests the opposite. An observation sits inside that web, not outside it. You don't observe the universe from a distance. You participate in it at the level of interaction. This is not philosophy. It's operational. Every experiment reflects this structure. And this is why attempts to talk about the universe as it is without observers keep failing. Not because observers are special, but because removing interaction removes the conditions under which properties are defined. No interaction, no measurement. No measurement, no outcomes. No outcomes, nothing to describe. This is where the idea of direct observation finally collapses. Direct observation would require a property that exists independently of interaction and is revealed without being altered. Physics has never found such a thing. Not once. Even space and time, which feel like the most fundamental background, turn out to behave this way. Time is not something you look at. You infer it from change. Space is not something you see. You reconstruct it from relations. Clocks interact. Rulers interact. Strip away interaction, and the concepts lose their meaning. So the problem is not that reality hides. It's that reality does not present itself in the way we expect. We expect revelation. Physics offers correlation. We expect essence. Physics gives us structure. And this brings us to the final discomfort. If you cannot observe reality directly, then certainty itself becomes contextual, not arbitrary, not subjective. Contextual. Certainty belongs to predictions within a framework of measurement. Outside that framework, the word loses precision. This doesn't weaken science. It defines it. Science is not about ultimate answers. It's about limits that do not move. Limits on what can be simultaneously known. Limits on what can be defined. Limits on what questions make sense. These limits are not negotiable. They are enforced by experiment. And once you accept that, something strange happens. You stop asking what reality is. You start asking what reality permits. What combinations of outcomes are possible? Which predictions survive contact with the world? This is a colder way of thinking, but it's also a more honest one, because the universe does not reward our desire for pictures. It rewards accurate calculation, and it does so without explanation, justification, or comfort. So when you hear that you can never observe reality directly, don't imagine a veil waiting to be lifted someday. Imagine a rule that cannot be broken, a rule that says knowledge comes from interaction, and interaction defines what can be known. There is no view from nowhere, only views from within. And physics, at its most unsettling, is the discipline that learned to live with that and still predict everything that can be predicted. What remains beyond those predictions is not a mystery waiting to be solved. It is simply not part of the deal. And once you truly understand that, you don't feel confused. You feel precise, but the comfort is gone. Because the universe is no longer something you look at. It is something that responds only when touched, and never on your terms.